So today is an extension of yesterday, but instead of multiplying, now we are dividing. So yesterday we said you could, like, things that are inside square roots or any kind of roots, you could multiply them together on the inside. So the same kind of thing happens today, but we can divide. So what is the square root of 36?
6.
What's square root of 5? 25. 5. Okay, now deal with it like inside. So inside we could write this as 6 over 5 squared, which the index 2 cancels out with the exponent 2, and we'd be left with 6 over 5. Okay, sometimes they'll even divide out more simple than that, but sometimes they won't. They do on this first example. Okay, so we can't take the cubed root of 32 and we can't take the cubed root of -4. So let's write them together in one big cubed root. So 32 over -4. Hey, we can divide that, right? Cubed root of, what's 32 divided by -4? -8. What's cubed root of -8? -2.
Okay.
Anytime you're taking an odd root of a negative, you can just, your answer is going to have a negative in it. Just know that. Okay. Next one. This one looks complicated. Separately, let's try it combining it. Okay, can we divide 162 by 3? Try that.
No.
You can't?
162 divided by 3?
Yeah.
You can't do it. Yeah, you can. 100 and, oh wait. Sorry.
Yeah, it's 54.
All over it.
Okay. 54, and then what about x to the 5th over x squared? Subtract them, so it's x cubed. Okay.
Wait, how did it 54?
162 divided by 3 is 54. Okay, let's break down our 54. What is...
6, 9, you're going to have a 3, that's in common 3 times.
Okay, so 6 and 9, keep going, 2, 3, 3, 3. So we have a set of 3s that come out. And then 2 stays in. And what happens with the x? One comes out, right? Because 3 goes into 3 one time, so x, the first power. And there's your answer. Okay, any questions now? Next one, can we deal with it as it is right now? And the 4th root of 4 down there probably isn't going to happen. So let's try to combine them. What's 1,024 divided by 4?
256.
Okay. I think if you tried to take the 4th root of 256, I don't think you would get an answer if you did that in the calculator. I mean, you get decimal, but maybe you would. I don't know. You do? It's 4?
Yes.
Okay, it equals 4. Ta-da! Didn't even have to break it down. But you could have and gotten that answer, but the calculator helped us out. So remember to put that in the calculator. You do 4 math 5, which is the little square root thing, and then put in your 256, and it'd give you 4. Okay. Any questions? Now. Alright, so the part that makes this lesson harder than yesterday is that it is division, which means we have fractions, and in your answers you cannot have a radical in the denominator. Okay, that's what I want you to write by that arrow. Cannot have a radical in the denominator of your answer. That's just like one of those math, like grammar things. But just don't want complicated things in the denominator. So, to get rid of it, we rationalize it. That's what it's called. And to do that, I'm going to write, so, you multiply the entire thing by 1. But you make that 1 look exactly how you want to. So that 1 will look like denominator over denominator. Whatever it is. Have we done this before? No? Okay. Just seemed very familiar in my head. I get confused sometimes. Okay. So let's try this. We can't take the square root of 2, can't take the square root of 3. We couldn't take this, and 2 divided by 3 doesn't make anything. So that's like our answer, except we can't have a root down here. So multiply by denominator over denominator. So square root of 3 over square root of 3.
I think we have this. Now that you write it out, yeah, we have.
We've done it
Yeah.
with something. Yep, multiply across, so square root of 6 over square root of 9, which is 3. So square root of 6 over 3. Can't simplify square root of 6 any, so there's your answer.
Could we just, put the 3, just take out the square root and just put the number? Okay.
I mean, that's eventually what you get to, yes. So, but sometimes, like you'll have something in front of the square root, so it kind of changes it a little bit. All right, let's try the next one. Could we go ahead and simplify anything out of this? The x's, right? This one can cancel with one of them up here. So it's square root of x squared over square root of 5y. Now can we simplify anything? No. I think you can.
X squared.
What's square root of x squared? Just x. Okay, so we have just x on top, and then square root of 5y on bottom. Now, what do we need to do?
Multiply 5y divided by 5y.
Square root of 5y
Yeah.
over square root of 5y, right? Okay, so what do you get on top?
X 5y.
Remember that x is not in square root, so it doesn't, it stays outside. So x squared of 5y over, what will you get on bottom, Megan?
25y.
No, 5.
5. Well, yeah, but like.
You get square root of 25y squared,
Yeah, and then
which-
that equals 5.
yeah, which ends up being,
Trying to get at.
yeah.
Equals 5y, right?
Yeah.
There's no imaginaries today, right?
Correct. No imaginaries today. Okay, now of course we got to make it a little more complicated by dealing with cubed roots. Okay. Let's write this as top and bottom. So I'm going to have cubed root of 2 over cubed root of 3x. Can we simplify any of that? No, not really. So we need to go ahead and rationalize our denominator. So what should we multiply by? Cubed root of 3x over cubed root of 3x. When you multiply that, what do you get on bottom? Cubed root of 9x squared. Can we simplify that yet?
The 3 comes out. Or, wait. No.
No. So what do we actually need to do since it was a cubed root?
Multiply by another?
We got to do it again. So whatever your root is, you need to make your denominator appear that many times. So like up above, it was squared. So we made our denominator appear twice, which meant only writing it one more time. But here, we made our denominator appear 3 times. It was already there, so we had to do 2 more. Okay, so we're not using this. So what will it be on bottom now? Cubed root of 27x cubed. Okay, what about the top? Cubed root of 2 times 3 times 3, 18x squared. Okay, we can simplify the bottom, because that was the point of this. What do you get? 3x, and then we can't do anything with the top, can we? No, because you see what it would break down into, a 2, a 3, and a 3. There's no sets of 3 there. Okay, so top is just cubed root of 18x squared. That's your answer. Questions? So if it was, say, you were taking the 5th root in the denominator, how many times would you have to multiply? 5. It'd have to appear 5 times, so you need to multiply by 4 times. Because it's already there once. Okay? Good? All right.